When a wave passes through a gap, it will spread out. Now this is a process known as diffraction, and if we just move this receiver, we can see that we're picking up a signal at much more angles, much more range of angles. So if you want to get the most diffraction, the most spread out, then what you want to do is you want to have the gap be length of the wavelength of the wave. Now let's just talk about double slit diffraction. So now the light is being diffracted once through this first slit and then again through two separate slits. So what are we going to observe as we move this sensor across? So take a good look at the needle. So you notice how it goes up and down. In order to understand what is happening with the double slit experiment, first we need to talk about interference. Interference is a phenomena in which the displacements of two waves are added together. So let us pretend that this is a wave and this represents the displacement or the amplitude of the wave. What's happening in this representation here is it's representing two identical waves being emitted at separate points. Let's see what happens when these two waves intersect. As you can see, at this point here, the phase of the wave is the same, and when the amplitude is added together, you get something big. This is called constructive interference. Conversely, when we have a wave in antiphase, the two waves will cancel each other out and you'll get nothing. This is called destructive interference. To give a better visual representation of this phenomena, I have passed this laser through a diffraction grating. So this is lots of tiny slits in this thing. And you can see the interference patterns just right here. Nice interference fringes. Now if I was to place another laser through this same pattern, you'll notice the separation between them, between the fringes, is different. That's obviously because the lasers are different wavelength. I have illustrated a diagram of the Young's double slit experiment detailing which positions you will have to be to observe constructive and destructive interference. Interference is a property that occurs in all waves, both transverse and longitudinal, as I will demonstrate with the speakers.
Let's go.
What did you do?
Was it? Oh, start. Right. There we go.